All right, we're going to get into how the periodic table is organized. So recognize that there are more than 100 elements and some have similar properties as shown on the periodic table of elements. That's kind of what we're looking for in this section here. So what is the periodic table? It represents our understanding of the structure and usefulness of the atoms that have been identified in our environment. Elements are organized on the periodic table based on similar properties. Okay. So here's our periodic table. You notice that this one doesn't have all the elements in it, but again, a lot of our periodic tables are old because we just found all the elements that we have. What do the numbers and the letters mean? Well, of course, we've already been over this. You should know that that is the element name, the atomic number, number of protons, and a number of electrons in a neutral atom. This is the element symbol, and that is the atomic mass. Not the mass number. Remember, mass number is different. Mass number is the total number of protons and neutrons. All right. So what do you notice about the atomic number of the elements moving left to right or up to down? They increase. Okay, so we increase our atomic number going across, and we are increasing going down. So, excuse me, the periodic table is organized like a big grid. So everything that's labeled on here tells us everything we need to know. The properties of an element can be predicted from its location on the periodic table. Remember, we said this periodic table is arranged by properties. So things with similar properties are going to be on the same, near each other. Put it that way. There are rows that go left to right, and columns that go up and down, and that means something different. So we have rows and columns. There are different types of elements that we can also combine them as. We have metals, that is all the yellows. We have nonmetals, which is all the greens. And if you notice over here, hydrogen, sorry, my pen. Hydrogen is a nonmetal, even though it's over here by the metals. And then we have metalloids. Okay, so let's look at metals. I want you to copy down what are some properties of metals. Metals are shiny. Metals are solid at room temperature. Excuse me. Metals have high conductivity, meaning they can conduct electricity and heat. That is a physical property, and it's intensive. It does not change. So if we wanted to learn, if we had gold or silver, we could see how they conduct electricity or conduct heat and which one conducts better. Metals can be flattened and not shatter. That is malleability. Now, some of them also have ductility that can be stretched into thin wires. Nonmetals. Okay, copy this down. This is this is like the properties of a nonmetal. Nonmetals are not shiny. Nonmetals are mostly gases at room temperature. They don't have to be, but they can be. They mostly are. Nonmetals are poor conductors. They don't conduct electricity. Nonmetals are brittle. They will shatter if you try to pound them into sheets. Okay. Then we have the metalloids. Make sure you copy this down. Their characteristics are between metals and nonmetals. So they kind of act like a metal, and sometimes they act like a nonmetal, depending on what they're bonded with. They are solids at room temperature, and they are sometimes called semiconductors because they sometimes can conduct electricity or heat, or they slightly do. All right, let's get into how the periodic table is arranged. We have periods. Periods are horizontal rows on the table. We can also, like I said, call these energy levels. Okay. Each row represents a number of energy levels represented in the atom. So if you go down, we have 7 periods. So we have right now 7 energy levels. Okay. The columns, which are the vertical columns, there's 18 groups, and we start. Let's see, it goes back. It starts right here, 1 to 18. Okay. The elements in a group have the same number of electrons. Make sure you copy all this stuff down here. If it's in everything right here, copy that down. have the same number of electrons in their outer energy level. Groups are often grouped together to form families because they have similar properties. So like this, you notice the whites are different. This group here, these are going to be the transition metals, which we'll go into in a minute. But those are not really, they don't really have all exactly the same things in energy levels. They do, but only to a point, okay? So they're not really a family necessarily. I guess you could call them a family. But you probably know a family with several members look alike. So do the elements in the group or family. They often, but not always have similar properties. So we're kind of, it's like at a glance, you kind of know that this is what's going to happen with this family or this group for the most part, especially when it comes to reactivity. Okay, so here's another look at our groups and periods. And there's 7 periods, 18 groups. Okay, so hydrogen. This is, I want you to know when we go back. Hydrogen right here. The properties of hydrogen do not match. And I want you to do this because hydrogen's kind of like its own little lone wolf. I usually call him the lone wolf because he kind of is all by himself. He does all kinds of different things. He's in group 1 because he has 1 electron, but he's a nonmetal and should be over by the nonmetals, but he's not. Okay. Then we have the alkali metals. Here's where they all like. So we're going to put these on our periodic table in class, so don't worry about writing them down. Alkaline earth metals, transition metals, boron group, carbon group, nitrogen group, oxygen group, halogens, and the noble gases. We have the rare earth metals, and we had the transition metals, which I kind of showed you in a minute earlier. So the periodic table also has some of them have different states of matter. You notice that the nonmetals, most of them are gases. And then we have a few that are liquids, and this is mercury. It is a metal that is a liquid at room temperature. Ignore this completed. I forgot to take that off. Okay. Atoms will often give, or share electrons with other atoms in order to have a complete set of electrons in their outer shell, which you'll learn is called the octet rule in another video. Elements whose atoms undergo such processes are called reactive and can combine to form compounds. Since groups are similar because they have the same number of electrons in their outer energy level, the periodic table is also organized by a degree of reactivity. And I will cover that in another video. Okay, so if you would, go ahead and copy these notes down and bring them to class. Oh, wait, I forgot this slide. Reactivity of elements. We're going to put this on our periodic table. Just know that group 18 is unreactive. And I'll get into that in just a little bit. This is what I want you to bring to class. I'm sorry, I knew I had one more slide. Name at least 3 ways a periodic table is organized, and this should be in your summary. Identify the two numbers given in an element, and identify the main purpose of the periodic table. All right. Now, come to class with your notes. Sorry.